Assalamualaikum and hi. Now, my friend and I would like to present about Wi-Fi and mobile signal in Physics 260. So, this is our group members. Alright, so introduction and theory. Wi-Fi. Wi-Fi is a type of wireless networking technology that makes it possible for gadgets like desktop and laptop computers, wearable technologies, smartphone and other devices to connect to the internet. It enables this and several other devices to communicate with one another in order to create a network. The wireless router is the device that connects to the internet. Your Wi-Fi capable devices can connect to the internet through the wireless router you can connect to when you see Wi-Fi. Alright, next, signal. In essence, a signal is anything that transfers data. It is a physical quantity that can be used to describe and communicate data because of its change across time or space. Signals are essential in many domains such as electronics, communication, and even biology, where they are employed for intercellular communication and data transmission in circuits. Any physical quantity that changes in response to one more independent variable can also be described to as a signal.
So, Assalamualaikum. Right now, I'm gonna explain to you guys the types of propagation Wi-Fi and mobile signals. Wireless signals, including Wi-Fi and mobile signals, propagate through the air using electromagnetic waves. These waves travel via different modes and are affected by various mechanisms that influence their strength and range. Key modes include ground wave, sky wave, and space wave, line of sight, while mechanisms like reflection, diffraction, and scattering impact how the signal reach the receiver. So we jump to the first propagation mode. The first one is ground wave. This mode follows the Earth curvature and is typically used for low frequency signals over short distance. The second one is sky wave. Signals are reflected by the ionosphere, allowing for long distance communication. And last one is space wave. Signals travel directly between transmitter and receiver, common in Wi-Fi and cellular network. The next one is propagation mechanisms. For the reflection, signal bounce off large obstacles like buildings and walls. For diffraction, signal bend around obstacles such as hills or buildings. Scattering signal are dispersed in multiple directions by smaller objects like trees or street furniture. And last one is multipath propagation. Signal arrive at the receiver through multiple paths due to reflection, diffraction, and scattering, which can cause signal network interference. Thank you.
Let's move on to the next part, which is application of Wi-Fi and mobile signals. So, Wi-Fi application for the first example is home and office networks, which is connecting devices like laptops, smartphones, and smart home devices to the internet. For the second example, public Wi-Fi hotspot. We could provide internet access in public places like cafes, airports, and libraries. The third example is Internet of Things, which is connecting various devices such as smart appliance, sensors, and surveillance cameras to the internet for automation and remote control. For the last example, which is indoor location system, by utilizing Wi-Fi signals for indoor positioning and navigation. So, for mobile signals applications, we have voice calls and text messaging, for connecting calls and sending messages between mobile devices. After that, mobile internet access for browsing the internet using mobile apps and streaming content on smartphones and tablets. And we have mobile broadband, which is providing high speed internet access for portable devices like laptops through cellular hotspot. And we have emergency services for supporting communication during emergency through cellular network. And last but not least, for location tracking, we could determine the location of mobile devices using GPS or cellular triangulations.
Advantages and disadvantages of Wi-Fi and Wave. We have three of advantages and three of disadvantages. For the advantages, first, security. To protect transmission of data, Wi-Fi networks can be secured. Second, high bandwidth and speed. Wi-Fi provides quick data transfer speeds, making it perfect for activities using a lot of bandwidth, such as streaming, gaming, and downloading big files. Third, interference resistance. By using less crowded frequencies, certain wave technologies can decrease interference and the risk of signal breakdowns. For disadvantages, first, security. Due to the flexibility through which signals can be intercepted, wireless networks are naturally more open to breaches of privacy than wired networks. Second, speed and bandwidth. Even if Wi-Fi speeds have increased, they may still be less than what is stated, particularly in busy regions where multiple devices competing for bandwidth. Last, interference. Slower speeds and unstable connections could happen when other electronic devices using similar frequencies to interfere with Wi-Fi signals.
Hi, so we go to the conclusion. Is to wrap things up, both Wi-Fi and mobile signals rely on the basic principle of electromagnetic wave, especially within the radio frequency spectrum. Grasping how they behave like how they travel, phase interference, and loose strength is key to boosting signal quality and connectivity. As wireless communication keeps advancing, understanding the physics behind these technologies is vital for driving innovation, improving efficiency, and tackling real-world connectivity issues. Thank you.